In introduction, we'll be begin by looking into the Val di Stava dam collapse, a real engineering tragedy that occurred in Italy on 19 July 1985. The collapse of two tailing dams released over 18,000 cubic meters of toxic sludge, destroying everything in its path and taking 268 lives. In this presentation, we cover the incident backgrounds, discuss its technical and ethical failures, related those to the Engineering Act, and finally share recommendations to prevent similar disasters in futures.
On July 19, 1985, one of Italy's worst industrial disasters struck the peaceful Val di Stava Valley in northern Italy. These two tailings dams used to store liquid mining waste from a nearby fluoride mine suddenly collapsed. This happened due to years of poor maintenance and flawed design of the dam, where the engineers constructed the upper dam directly on the lower dam. This means that the upper dam wasn't supported by compacted soil but by loose, unstable sludge. At 12:20 p.m. on the day, the upper dam gave away, triggering the collapse of the lower dam just moments later. A massive wave of 180,000 cubic meters of mud and debris slashed down the valley at nearly 90 kilometers per hour. In just minutes, it destroyed homes, hotels, and factories, killing 268 people, and many of them are tourists and local residents.
Hello, my name is Zahin, and I'm going to present about technical and engineering issues. Now, let's take a closer look at the technical and engineering issues that contribute to the failure of the dam. On the left, we see design and construction issues. The slope stability was poorly analyzed. They overestimated the soil strength and didn't consider water pressure from rain, which weakened the dam. The drainage system also failed, pipes bent and leaked, and water built up because there were no filter or drains. Plus, the dam was built on the weak soil using a risky upstream method. On the right are monitoring and maintenance issues. There were no systems to track pressure or leaks and early warning. Also, no risk assessment or emergency plan was in place for people living nearby. This engineering's oversights and a lack of monitoring demonstrate how technical abandonment and bad planning can have devastating consequences. This slide highlights two more major problems: neglect of professional ethics and regulatory non-compliance. On the left, engineers and decision makers failed to follow ethical standards. They ignored international guidelines like ISSMGE and ICO. They skipped independent reviews and even kept known risks hidden from the public and authorities. On the right, we see a lack of proper regulation. The construction started without the required permits or oversight. Worse, local authorities allowed unsafe practice and let people build in dangerous downstream areas. Together, these ethical lapse and weak regulations made the failure much more likely and far more dangerous. For this slide, I will go over 5 lessons learned for technical and engineering issues that are crucial for safe and successful projects. For the first one is thorough geotechnical studies. Second one is reliable slope stability and drainage design. Continuous monitoring, independent safety audits. Last but not least, ethical responsibility and transparency.
My name is Iqbal and I will continue with ethical reasons for failure. Okay, now let's explore the ethical failure behind the Stava Valley Dam collapse. We will compare this Malaysia framework, including the Registration of Engineer Act, the IM Code of Ethics, and the Malaysia Anti-Corruption Law. This law stress competence, safety, and anti-corruption essential to prevent such as engineering disaster. Engineering failure often stems from the ethical violation. This type highlight the key causes like a poor dam design and lack of safety monitoring, linking them to violations such as incompetence, environmental irresponsibility, and gross negligence. Each issue directly breached the IM regulation and Act 138, underscoring the legal and professionality as engineer must uphold. To prevent failure, engineer must uphold core ethics, stay within your competency, prioritize safety, protect the environment, assess the risk properly, and always act with integrity. Never compromise life for cost.
Next, let us look at the recommendation to prevent future dam-related problems. There are three main recommendations: proper engineering design procedure, regular maintenance, regular reporting, and inspection. For the engineering design procedure, the dam design must be carried out by an professional engineer with practicing certificate, the process should be advised by an engineering consultancy body and reviewed by an accredited checker. For regular maintenance, the operating company is responsible for both conducting the maintenance and preparing a detailed maintenance plan, including procedure and requirement. The relevant authority must supervise and monitor this maintenance activity. Finally, regarding reporting and inspection, the government should enforce mandatory reporting by the operating company, carry out regular inspection, investigate any irregularity, and take action against parties who found guilty of negligence. This ensures the structural integrity of the dam is continuously monitored, allowing for early action and reducing the severity of potential accidents.
In conclusion, the Val d'Istava tragedy was not just a structural collapse, it was a collapse of professional responsibility. Poor design choice, ignored warning signs, and failure to follow engineering standards under the Engineer Act led to the loss of 268 lives. This disaster reminds us that technical knowledge alone is not enough. Without the ethics, accountability, and the courage to act, even small oversight can cause irreversible damage. To prevent future tragedies, engineers must follow strict codes, act with courage, and uphold the ethics that protects life. That's all from us. Thank you.